right, so this is the magnetism practice page. We're going to go over it real quick. All right, so number 1 says list the similarities between magnetic force and electrical force. So similarities means properties that are going to be the same. So both magnetic force and electrical force, when you have locks attract, or I'm sorry, they repel, and opposites attract. Remember when we had the 2 plus signs, they repelled one another, and when we had a plus and a minus, they were attracted to one another, and that was the same for magnetic force and electrical force. All right, number 2, it says list a similarity between magnetic force and gravitational force. So both of these things can work at a distance. They don't have to touch. So they don't have to touch in order for them to either push or pull. Remember when we said that a magnetic force allows the 2 objects to work at a distance, they don't have to be touching. Gravitational force is the same way. It does not have to be touching in order for it to push or to pull the objects down. All right, number 3 says draw a picture to show what happens if you break a magnet in half. All right, so we've got our magnet, and it has a north pole and a south pole. If we break the magnet in half, remember, we don't get just a north and just a south. We're going to get 2 new north and south poles. It makes 2 new independent magnets. On number 4, it says, how would it be possible for magnets to apply a force over a distance? So, the way that they do that is they have a magnetic field. So remember that magnetic field works on the outside of the magnet. So remember we had these magnets, and you did not have to draw this. I'm just going to draw this so it shows you a little bit better about what's happening. Remember, we have locks that attract one another, and it goes like this, and then we've got this that's going to be going this way, and then we've got them going this way. Remember, we had all of those iron filings on around the magnets, and they worked at a really large distance. Like even out here, the magnets would have worked. And the way they work is because they have a magnetic field around the actual magnet. All right, it says draw the lines of the magnetic field coming out of the magnet with the north on the left and the south on the right. So we basically just did that, but we're going to go ahead and draw it again. So we've got our magnet, and we've got a north end and a south pole. And remember, all of the magnetic fields go out of the north and go into the south. And they work at a distance. So we're going north to south. And it's coming out of the north end and into the south end. So remember, if I ask you to draw this, your arrows need to be going the correct direction. And you have to have arrows. You can't just have lines. Number 6 says, in the magnetic elements, each atom's magnetic domains are aligned, which creates a magnetic field in non-magnetic elements. Each atom's magnetic domains are not always aligned. So the resulting element is not magnetic. So remember in this one, we had the nail, and we had those arrows just going every which way. Y'all remember that? They were just going all over the place. But then when we put a magnet beside it, they started to line up, and they all were going in the same direction. So this was in your notes. If you don't remember, look back in your notes. Number 7 says, what must you have in order for ferromagnetism to occur? So you have to have an object with a really strong magnetic field already. And if you don't remember what ferromagnetism is, you need to look back in your notes, because ferromagnetism, remember, it's when you have a very strong magnet that lines up next to an object that has the potential to be a magnet, but it's not without the strong magnet next to it. So on your notes on the back page, it says ferromagnetism, phenomenon where objects placed in a strong magnetic field becomes magnetized due to its poles within their atoms aligning. So remember, we have this nail that's not magnetic when it's just by itself, but when you put the strong magnetic field beside it, all of those electrons align, or all the atoms align, and it becomes a magnet. All right, on number 8, it says, what can moving electric charge produce? In what direction is it generated? So in your notes, it talks about a magnetic field can be created with an electric current. And remember, in your notes, it drew the arrow and then it drew the magnetic field going counterclockwise. So counterclockwise is the direction that it's generated. And remember, that was called an electromagnet. So it says, what is necessary to create an electromagnet? You need a piece of metal, and a current carrying coil of wire. So if we go back to our notes and we look at electromagnet. So here's your electromagnetic note. It says electromagnet. It's a temporary magnet made by placing a piece of iron inside a current. So the more loops you have on the wire, the stronger the magnetic field, the stronger the current, the stronger the magnetic field. And if you don't remember that, go watch your video notes. It shows you a picture and it shows you how the current works counterclockwise, and you have the wire around a nail. On number 10, it says, in what 2 ways can you increase the strength of an electromagnet? Well, we just learned that in our notes. So one way is to increase number of coils or loops. And the second one is increase strength of current. All right, so that is going to be your magnetism page. You need to correct yours if you've not already done so.